Power is defined as the rate at which work is done. So power is equal to the amount of work done divided by the time. The units for power are watts, which is abbreviated with a capital W, which you need to be very careful that you don't confuse that with work, which that is abbreviated with a capital W, but its units are joules. So be very careful when you're writing your units and your variables that you know whether you're writing a unit or a variable. Power is a scalar quantity, even though work is a vector. The reason why is a little bit complicated and deals with calculus. So we're not going to have to go into that. Just know power is scalar. The definition equation for power is work divided by time. But we know that work is also equal to force times displacement. So we can also write that as force times displacement divided by time. But displacement over time is also velocity. So power is also equal to force times velocity. So depending on what variables you're given, you may be using work divided by time, or you can also plug in the force times the velocity. Here's one example. Bart runs up a 2.91 meter high flight of stairs at a constant speed in 2.15 seconds. If Bart's mass is 65.9 kilograms, determine the work which he did and his power rating. Well, the first thing we need to do is find the force, because this actually gives us mass. Because he is going at a constant speed, we know that the force he's exerting must be equal to his weight. So we have force is mass times the acceleration due to gravity. Plugging in 65.9 as his mass and 9.81 as the acceleration due to gravity, we can find that the force he's exerting is 646.479 newtons. This isn't our final answer, so we don't want to round it yet. We're going to take that force and plug it into the work equals force times displacement equation. The displacement is 2.91 meters. So when we get that, it would be 1,881, etc. joules of work. Since it's asking for both the work and the power, I am going to record the work to the correct number of significant figures, which would be 3. So it would be 1,880 joules of work. And then when we go to find power, we are going to use the entire work amount divided by the time, which it tells us is 2.15 seconds. This is our final answer, so I'm just giving the answer here to 3 significant figures, and it ends up being 875 watts. Again, remember here that W, watts, is the unit for power. This W over here is the variable for work in the equation.